We live it every day. It's in our veins. It's under our feet. It's in our meals. It drives our storms. It changes the course of history itself. It's that water cycle we remember from elementary school.
This is the cycle of water by which all life survives.
But the picture is so much more varied, so much more vital than a few arrows can represent. Trying to measure that complexity from both Earth and space is an infinite task, but observations from NASA and many worldwide partners have led to quantum leaps in our understanding. In the last 60 years, we've seen a revolutionary change from relying principally on ground measurements to satellite observations of rainfall, to worldwide measurements of rain and snowfall every half hour. From space, we can now monitor soil moisture every few days and detect changes in aquifers deep underground. But we can't see every drop of water everywhere all the time. And water issues are incredibly localized, as unique as the landscapes the water flows over. To fill in the gaps, see the local picture, and project into the future, we use powerful computer models. These models pull in an incredible amount of data, like those daily scans of precipitation, but also rely on our understanding of the planet from all those decades of ground-based hydrology and soil research. In every corner of the Earth, these models help people understand critical issues like water availability for irrigation, drought severity, flood risk, and the likelihood of crop failures and famine. One of the trickiest parts is understanding how we impact the water cycle, with the multitudes of water use decisions we make every day that lead to things like diverting surface water, pumping from aquifers, and changing our planet's climate. In addition to collecting data and running sophisticated computer models, NASA funds a robust set of projects to help water managers across the United States address their specific water issues, from crop forecasts in the breadbasket, to snowpack in the mountains, to flood risk from nearby rivers. NASA's water observing fleet will expand in 2021 with a satellite that will collect data on surface water height and slope, which will enable estimation of river flows. With these observations, we will be able to observe all major parts of the water cycle from space: precipitation, evaporation, runoff, and water storage. Our view of Earth's water cycle will never be perfect, never be complete, but each advancement we make holds the promise of helping us prepare for the future, avoid conflicts and mitigate disaster, feed the world, and make good decisions about our most precious resource.